Okay, homework 10, symmetry and relations and functions. Okay, we're going to talk about for these first problems, symmetric to the y-axis, symmetric to the x-axis, and symmetric to the origin while looking at a graph. I'll explain all this in a few minutes. That's when we're doing it algebraically. Okay, so in these first problems, what you're going to do is let's figure out which ones are symmetric to the y-axis. Here is the y-axis. The left mirrors the right. So this one is symmetric to the y-axis because here's that y-axis. And if I folded it on top of it, it would be symmetric to the y. This one, however, is not. Okay? This left side does not look like the right side. And that is really a bad line there. Okay? This one, it is. See how this left mirrors the right? So it is symmetric to the y-axis. Now again, here's what you can do is we're talking about this y-axis. So if I was talking about, let's say, this point right here, from the y-axis, there's a 1, 2, 3, 4, 5 units to the right. Well, there's a point 1, 2, 3, 4, 5 units to the left. Same thing like right here. There's 2 units to the left, there's 2 units to the right. That's why it's symmetric to the y-axis. Okay, so down here, obviously this one is not, because there needs to be one like here if it was. This one here, it is not, because even, let's say we have this line, okay, our axis of symmetry is what we are going to call it later. See how there's a point 2 units to the right? There's not one to the left. So, nope, it's not. Same thing with this. You'd have to have one coming out like this, and it's not. Okay, so those are the only two that are symmetric to the y-axis. So we're going to talk about the x-axis. So this one, or these I should say, I had to erase all my, we're talking about this here. Does the top mirror the bottom? And it does. 5 units up, 5 units below. Okay, so this one is symmetric to the x-axis as well. This one right here, it is symmetric to the x-axis. 1 unit above, 1 unit below. 2 above, 2 below. It mirrors each other. So this one is symmetric to the x-axis. And this one is not, because the top does not mirror the bottom. Right here, it does not, because this top, there's nothing down here, so it doesn't mirror. This one right here, if it was, okay, you would have something, this is 3 units above, you'd have one that's 3 units below, right below it. So it does not mirror the top and the bottom. And same thing with here, you'd have to have one that goes like this. Okay. Now it doesn't have to be symmetric to any of them. Okay. All right. So those are pretty easy. Now this symmetric with respect to the origin, looking at a graph, because see, it can be none. Now this one's going to be kind of odd to you. So think origin, odd, because what you're going to do is you are going to actually put your pencil, I got a couple pieces of paper here, so it's going to be weird, okay? You're going to put your pencil in the middle, and you're going to turn your paper 180 degrees. And if your figure looks the exact same as it did when we started, then it's symmetric to the origin. So look at it right here. When I turn it upside down, it looks the exact same. So this is also symmetric to the origin. This one won't be, because look, it's on the right hand side, right? When I turn this upside down, 180 degrees, just turn it upside down. It's now on the left side. So it doesn't look the same. Again, this is on the left. The original was on the right. So no, it's not. And this here, it opens down. When I turn it upside down, it opens up. So it is not. This one is it is symmetric to the origin. Okay. It's down on the right. I'm sorry, down on the left, up on the right. So when I turn it upside down, it's still down on the left, up on the right. So this one is symmetric to the origin. It's kind of difficult. With my document camera, it gets in the way. Okay, now, this one right here. So I basically just look at this part right in here. All right. So you can say I've got a valley here on my left and a hill on my right. So if I turn it, I have a valley on my left, a hill on my right. So this one is symmetric to the origin. And then this one here, it's up on the right. If I turn it 180 degrees upside down, it's down on the left. So it is not symmetric to the origin. It's not symmetric to anything. Okay? Now remember, origin, odd. Origin is odd. Okay? Now other than the circle, this had to go through the origin. So, okay. That is if you're looking at a graph. Okay, so now, well, same thing for right now. We're still looking at a graph. Okay, so I'll explain all this in just a minute. So determine whether oh, never mind. We're talking about even and odd. Okay, for it to be, now, after what we just did, we're not really ever going to figure out symmetric to the x-axis. We're not going to use that anymore. If it is symmetric to the y-axis, it is an even function. Okay? It is an even function if it's symmetric to the y-axis. If it's symmetric to the origin, it is odd. Think about turning your paper upside down. That's odd, right? And that's how we check for symmetric to the origin. All right, so we're going to see if it's even or odd or neither. Again, we got to figure out whether it's symmetric to the y or the origin. This one definitely, let's first do evens. Okay, the left has to mirror the right. This one is, because it's symmetric to that y-axis. And this one is, because the left side mirrors the right. So these two are even. All right. Well, this one's not going to be either because it doesn't, in order for it to be odd, it has to go through the origin. So this one's neither. Okay. So remember, we got to turn it upside down. We've got a hill and a valley. So we need to make sure when you turn it upside down, you have a hill and a valley. So we do 180 degrees. We got a hill and a valley and a hill, and that's what it looks like. Hill, valley, hill, valley. When we turn it right side up, hill, valley, hill, valley. It's just easiest to explain it that way. So this is an odd function. This one, if I turn it upside down, it doesn't even go through the origin, but right now it is hitting the y-axis at 1. If I turn it upside down, it's hitting at a -1. So this one's neither. And then this one here, it's down on your left, up on your right. So when I turn it upside down, it's still down on your left, up on your right. It looks the exact same. So this is an odd function. Okay. Now, this one right here, determine algebraically if the function is even, odd, or neither. Now, the directions say algebraically. It doesn't just say guess. You got to prove it. Okay? You're probably going to look and go, oh, even function, odd function, odd function. Okay, if that's your guess, that's your guess. Let's prove it though. How do we do this? Determine it algebraically. So what we're going to do is we're going to plug in a negative x wherever we see x. So we're really going to do f of negative x. Well, what that means is you take your f function and you plug in negative x wherever you see x. Okay, so I'm going to take this x out and replace it with a negative x. I'm going to take this x out. It's minus, but I'm going to take that x out and I'm going to replace it with a negative x. Now I am going to work the problem. I have a 2. This here, that gives me a positive x to the 4th. Negative x times negative x times negative x times negative x gives me a positive x to the 4th. I have a minus sign. Now this part right here, that part there gives me a positive x squared. That part right there. Don't worry about that. That gives me a positive x squared. So, but when I bring it down because of that minus sign, it becomes that. Plus 2. Okay? All right. Now what we're going to do is we are going to compare this to our original function. If everything is the same, it is even. If everything is the opposite signs, then it's odd. So for even, all signs have to be the same. In this case, it looks the exact same as it does up here. Positive 2x to the 4th minus x squared plus 2, so it is an even function. Okay? Now, let's work this one here. Okay? In order for it to be odd, all signs change. If only some of them change, it'll be neither. Okay? Now again, the algebraically determine algebraically, this is what I have to see. You're going to plug in a negative x. Alright, so we're going to have negative x to the 3rd power minus a negative x plus 3. Okay? Negative x to the 3rd power minus a negative x plus 3. Okay. Negative times a negative times a negative gives us a negative x to the 3rd. A double negative becomes a positive x plus 3. So now I'm going to compare this with our original problem. In order for it to be an even, all the signs are the same. Well, that's not true. Okay? In order for it to be odd, all the signs have to change. This one changed, positive to a negative, negative to a positive, but this is still a positive 3. So this is a combination, some changed. So this one is neither even or odd because the 3 did not change. This 3 would have had to have been a minus. All right, so let's try this one. Again, same thing. We're going to say negative 4 times negative x to the 3rd minus a negative x. So what I did was I took out my x and I replaced it with the negative x. Okay, so right here I'm going to bring down my negative 4 times this part right here. Negative times a negative times a negative is a negative x to the 3rd. This gives me a positive x. Double negative is a positive. But a negative 4 times a negative x to the third gives us a positive x to the 4. I'm sorry, x. Let's try this again. Positive 4x to the third plus x. All right. Again, I could have probably did it like this. It would have looked better maybe. Anyway, it just means multiplication. Negative times a negative is positive. Okay, I'm comparing this with our original one. This was a negative 4x to the third. This is positive 4x to the third. This is minus x. This is plus x. All signs changed. So this one is odd. That is how, if your instructions, if you have one on your test that says determine algebraically if the function is even or odd, I got to see this work. Okay? It's kind of like proving it. All right, piecewise functions. This is where they give you, it's a function in pieces, like this f of x. It's in pieces. You use this part if x is less than 0. You use x minus 1 if x is greater than or equal to 0. So what you have to do is you've got to look here first. This telling you this, we know this, plug it in. This is our x. So in this case, x is equal to negative 1, here x is equal to 5, and here x is equal to 0. What you've got to find is where does this negative 1 fit in? Does it fit less than 0, or is it greater than or equal to 0? Well, negative 1 is less than 0, so you're going to use this x squared plus 1. You're going to take out your x, oops, okay, you're going to replace your x with the x minus 1, or with a negative 1, because negative 1 fits here. So you're going to say negative 1 squared plus 1. That's what I've done. This gives me a positive 1. 1 plus 1 gives me 2. Okay? Right here, 5. Where does 5 fit in? Is it less than 0 or is it greater than or equal to 0? Well, 5 fits right here. So you're going to use this function right here. You're going to put 5 minus 1. And that gives me 4. And then you got to find out where 0 fits in. Well, right here, because of that equal sign, 0 fits there. So I'm going to plug in 0 right here. I'm going to have 0 minus 1, which gives me a negative 1. Okay. Well, this one have an h of x function, and it's split into 3 different parts. Now again, we got to look here first. Where does 1 fit in? Well, 1 is less than 2, so I'm going to plug in 1 right here. I'm going to say 1 squared plus 3. Well, 1 squared is 1 plus 3 gives me 4. 2. Where does 2 fit in? It fits in right here because it's x is 2 is less than or equal to x. Well, that means 2 fits in here, which is kind of nice because I don't have to do any work. It's just 7. Find out where 3 fits in. Well, 3 is between 2 and 4, so we're also going to use this one for 3. So, again, it is 7 if our x is 3. And then 5. 5 is greater than 4, so it fits in right here. So I'm going to take this x squared, I'm going to take this x out, and I'm going to replace it with 5. So I'm going to have 5 squared is 25, plus 3 gives me 28. And that's how you handle piecewise functions. Okay, increasing and decreasing and constant. Okay, things you've got to keep in mind. This is going to be x values only. Okay, and you only use parentheses. Okay, And the reason is you can't increase and decrease at the same time. They're just stopping points. Okay? So the hardest part to this is you're going to want to go up and down, and you're going to want to use your y values, but you can't. You got to use your x values. Okay? So if I was to put in all my x values, here's -1, -2, 3, -4, and over here we got 0, 1, 2, 3, 4, and 5, because they already labeled that for us. All right, I'm going to go back to my post-it notes. All right, right here, from here, now we start left and go right. See how it increases? It goes up. From this point, actually, really from here, because it keeps going, right? Okay, so this is going towards negative infinity. So as it's negative infinity, okay, so from negative infinity to -2, it increases. So parentheses, negative infinity to -2, and we're going to do parentheses, because at that point it's not increasing nor is it staying constant. Okay, then it just stays constant from that -2 to 0. So parenthesis -2 to 0, and again parenthesis because it's not increasing, it's not decreasing, it's not constant. It can't be increasing and constant at the same time. It's one or the other or neither. Okay, so right here it is going to go down between 0, x being 0, and 2. It decreases. So it's decreasing from 0 to 2. Again, we're only talking about this part right in here, okay? It's kind of like my increasing was this part right in here, because it's x values only. That, of course, wasn't doing either, okay? Because it was staying constant. Well, now it's increasing again. So from 2 on out to our infinity. So it's increasing again. So, oops, union, gotta have room there, to infinity. Okay. The hardest part to this is people are going to want to be using your y's. You can't think that way. X values only. Okay. Now, right here, starting from the left, it decreases. It gets to this point and it still decreases. It just doesn't decrease as sharply. And it gets to this point, it still decreases. It never stops decreasing. It just doesn't do it as quickly. Okay, so this is decreasing from negative infinity to a positive infinity. And we don't have any increasing or constants there. Okay. This one right here, determine local minimum maximum of a function. All right, using a graph. So what we're going to do here is, it's really weird on how they ask it. Okay, this is a minimum. Okay, that is the point -1, -2, and that's a minimum. This is a maximum right here at the point 2, 3. And then we have another minimum right here at 4, 0. Okay? Now, if I asked you for the minimum and maximum and I said an ordered pair, you just give me those points. Okay? If I ask it like this, or Alex asks it like this, okay, these are your y values, value or values, and all values at which f has that local minimum, that's your x value. Okay, or values, depending on if there's one or two. Because there's two minimums, we have a minimum right here, okay, at -2. We have a minimum right here at 0. All values at which has a local minimum, that's your x value. So it's at -1 and at 4. Same thing here. We only have one maximum. So this is going to be my y value of that maximum. And this is going to be my x value of that maximum. So we have a maximum at 3. All values at which it has at is going to be 2. Over here, all we have is one minimum. That is the point 1, 2. So it has all local minimum values of 2, and all values at which f has a local minimum is 1, because again, y value, this is x value, and there aren't any maximum values, so I'm just going to write none. Okay? Now, this one here. Got to be able to use your calculator. I wouldn't use the one on Alex, okay? It even says this, okay? And the reason is you're not going to be using Alex on your test. You'll be using your calculator on your test. So here's what we're going to do. We're going to plug this in to your calculator. You're going to go to y equals, and you're going to plug it in, okay? So the first thing is y equals, and then you plug in your function, okay? So it's a long one, 2x raised to the 4th. Make sure you use your right arrow key to drop it down. Minus 4x to the 3rd power. Make sure you use that arrow key. Then finish it out. Minus 6x squared plus 3x minus 5. Just double check. Make sure you have it all right. Looks good. Okay, it says all points where there is a minimum. All right, so we're going to write this as a point at this point, okay? We're just going to want like 1, 2. It doesn't say what to round your decimals to, but I'm going to say round it to the nearest 10th. Why? Because it's fastest, okay? Now, we need to, let's see if this is in the right zoom, okay? So I'm going to hit zoom 6 for standard. Okay, so we got a problem because we can't see this minimum. It still would work. We don't have to fix our window, but I'm going to have you fix your window. All right, so if you see something like this, -10 to 10, 1, and I already know what this needs to be set on. Let's go -30 to 10, and let's count by 5s. Okay, if you see this, these are your x and this is your y, and you're going to hit your window, because what needs to happen is I want to see this point down here. My y is only going to -10. Well, it needs to go lower, so you're going to hit your window. This is -10 to 10. We're counting by 1s. But I need this to go lower than -10. So I'm going to move that to -30 to 10. And I'm going to count by 5s. Because counting by 1s, those little lines are going to be small. It doesn't matter. It would work. And now let's hit graph. Okay, we can see it. All these little hash marks are counting by 1s. These are counting by 5s. Okay, so we are trying to find a local minimum. Now, so we've done y equals. We've plugged in our function, right? And what we're going to do is we need to go find, and then we hit graph just to see what the graph looks like. So in order to find minimums and maximums, they're going to be the exact same. You are going to hit your second button. Then you're going to hit trace because it turns trace into calculate. Okay, so when you do that, you hit second trace, it brings this up. We're wanting to know minimums, so you're going to hit 3. If it asks for maximum, you'd hit 4. So I'm just going to write 3/4 depending on, or actually I'm just going to say min/max because you got to pick at that point. And because we are trying to find a minimum, I'm going to pick 3. Now, it asks you for your left bound. Well, here is my minimum. Okay, right there. I need my cursor to be on this left-hand side. So I'm going to hit my left arrow key so that it's left up. It can be anywhere on this left side. It does not matter. Okay, I'm just going to leave mine there. You can leave yours like in here. That's perfectly fine. Now hit enter. All right, well now it asks for the right bound. So you got to go on the right hand side of where my pin is. Anywhere, it doesn't matter. Hit enter. Now, see these arrows? That minimum should be between those two arrows. Okay? Then it just asks for a guess. If you want to move your cursor to here, you can, but I'm not going to. I'm just going to hit enter again. And I'm going to round this. Yours may be slightly different than mine. But when we round to the nearest tenth, everybody's will be the same. So this is a negative 0.8, comma, negative 8.4. Now I have another minimum. Okay, in order to do that, I've got to go through it again. Second, trace, 3. And I'm going to go find this minimum, even though I know there's a maximum. But let's go find this minimum. Is this on the left-hand side of that minimum? Yeah. So I'm just going to hit enter. Now it needs to be on the right-hand side. Put it anywhere on this side. I don't care. Hit enter and then hit enter again. And we're going to get 2.1, comma, negative 23.3. And again, yours may be slightly different than mine, but when you round to the nearest tenth, it will match. Okay? So we hit second trace, we picked minimum and maximum. You placed it on the left side. You hit enter. You placed it on the right side. Hit enter. And then you hit enter again. And it gave you the answer. Okay, well, we need the maximum for this, okay? So here's a maximum right here. Oops, let me move my calculator, sorry. My maximum, oops, what did I do? Okay, is right here, okay? So I'm going to hit second, trace, and instead of picking 3 for minimum, I'm going to pick 4 for maximum. Okay, I've got to put it on the left-hand side of this hill. Someplace. It doesn't matter. I'm going to put it right there. Why? I don't know. It's just there. Hit enter. Now it needs to be on the right hand side. It doesn't matter where. Hit enter. As long as this hill is between our two arrows and our dotted lines, some of you don't have the dotted lines, we're fine. And hit enter again. And we have 0.2, comma, negative 4.7. Okay. Now we're just going to change. We're going to change our function. And I'm just going to doctor mine. I'm not going to type it all over. So I'm going to get negative 3x to the 4th plus 2x to the 3rd plus 3x squared minus x plus 3. Again, always double check your function, make sure it's right. Okay, now if you want, you can pause it if you're not done. All right, so we're going to find our local minimum. So that means, again, I am going to hit my second button I'm going to hit, oh well, hold on. Let's graph it first because I need to see what it looks like. And I think we can move this again. Okay, it's fine. We can do this, but I'm just going to go back to Zoom 6. Oops, not that. I'm going to hit Zoom. I hit second 6. Let's hit Zoom 6 for standard. But you could have left it. It wouldn't have been a big deal. But Zoom 6 is where we mostly work. All right, so we got two maximums and a minimum. Okay, I'm just going to start with this maximum here. Second calc. Oh my goodness, let's try this again. Second calc. There we go. See, you can't really mess this up. Okay, I hit the wrong button. I hit alpha instead. So hit second calc 4 for maximum. I'm going to get this left hand maximum right here. So it's on the left hand side. I'm going to hit enter. Go to the right hand side, hit enter again. And I have one maximum at, well, there we go, at negative 0.6, 3.9. Okay, I'm going to go and find this minimum now. Second trace 3 for minimum. It is on the right hand side. I'm just going to hit enter. I'm going to go, I'm sorry, it's on the left hand. I don't know my right from my left. It's late. Now I have on my right bound, now my guess, and my minimum is going to be at 0.2, 2.9. And then I have another maximum, second calc 4. That's on my left hand side of it, so I'm just going to hit enter. I could have moved it. I'm going to put it on the right hand side, hit enter, and then I'm just going to hit enter again, and I get 0.9 and 4.0. 0.9, 4.0. Okay, and I think that's it.